You've seen it, right? AI like ChatGPT just writing these incredible essays, or your phone translating a menu in real time. How does it do that? Well, the secret isn't just about throwing more data or faster computers at the problem. Nope. It's this brilliantly simple yet powerful idea called the attention mechanism. It's the thing that finally taught AI how to focus. So let's get right into the core problem they were trying to solve. Think about this. How does an AI read a really long sentence and not forget what was said at the beginning? I mean, you and I do it all the time, right? You remember the subject of a sentence by the time you get to the verb. But for early AI models, that was a huge issue. They had, to put it mildly, a terrible memory. All right, so here's the game plan for this explainer. First, we'll dig into that AI forgetting problem. Then we'll look at the elegant, human-like solution they came up with. After that, we're going under the hood to see how attention actually works. We'll talk about the transformer, which was a total game changer, see where else this idea pops up, and finally, take a peek at the future of AI focus. Okay, first up, the AI forgetting problem. Let's really get a feel for the brick wall that researchers were banging their heads against for years. It all boils down to the way older models, specifically something called recurrent neural networks, or RNNs, tried to handle information. So, picture this. An RNN reads a sentence one word at a time. And with each new word, it has to update this single little piece of memory, a vector, which is just a fancy name for a list of numbers. It's trying to cram the meaning of the entire sentence, everything it's seen so far, into this one fixed-size box. Now, for a short sentence, the cat sat, okay, no problem. But for a long, complex one, it's like trying to stuff an entire encyclopedia into a Post-it note. Things are going to get lost. And this right here is what happens. It's a huge problem called long-range dependencies. Basically, if the most important word is at the beginning of a paragraph, by the time the model gets to the end, that crucial context is just gone. It's been pushed out and overwritten. The model literally forgets, and what it produces can be completely inaccurate or just plain gibberish. This memory bottleneck was the thing holding the entire field back. So what's the fix for a model with a terrible memory? Well, researchers did what they often do. They looked for inspiration in the best information processor around, our own brains. And the solution they found was, honestly, incredibly intuitive. This was the light bulb moment. Think about how you read. You don't treat every single word with equal importance, do you? Of course not. Your brain naturally zeroes in on the key words, the nouns, the verbs, the important context clues that give the sentence its real meaning. So the big question became, what if we could teach an AI to do exactly that? And boom, that's how we got the attention mechanism. It's basically a technique that lets the AI model look at the entire sentence all at once. And for any given task, it can dynamically weigh the importance of different words. So no more trying to stuff everything into that tiny memory box. Now it has access to the whole sentence all the time, and it just learns where to look. All right, learning where to look sounds great, but how does a computer actually do that? It's not magic. It's a really clever system that boils down to three core ideas: queries, keys, and values. Let's pop the hood and see how this QKV system works. Okay, let's use an analogy. Imagine you're in a library. The question you have in your head, that's the query. Now, every book on the shelf has a title, like a little label. Those are the keys. You compare your query to every single key, every title, to see how well they match. That gives you a score. The books that seem super relevant get a high score. The others get a low score. And the actual information inside the books, that's the values. So what happens next is the cool part. The final output isn't just one piece of information. It's a mix, a weighted sum of all the values, all the information. But here's the trick. The weights are those relevant scores. So it's like turning up the volume on the really important information and turning the volume way, way down on everything else. It's the original data just viewed through a lens of what actually matters. The AI has learned to focus. Now, this attention idea was awesome, but for a little while, it was just kind of a neat trick you could add on to the old RNN models. But then came 2017, and everything changed. A single research paper dropped that took this one idea and made it the absolute centerpiece of a brand new AI architecture. And that sparked a revolution. So, before 2017, the world was dominated by those clunky RNNs we talked about. Then, this paper comes along with maybe the best title in AI history, Attention is All You Need. It introduced the world to the transformer model, a design that completely tossed out the old one-word-at-a-time process. And after that paper, the floodgates opened. The AI you hear about today, GPT, BERT, you name it, they are all descendants of this transformer architecture. So what was the transformer's secret sauce? Well, a few things. First, something called self-attention. This is huge. It means every single word in a sentence can look at every other word in the same sentence to figure out the context. It's a web of connections, not a one-way street. Second, parallel processing. Since it wasn't stuck going word by word, you could process the whole sentence at once. This made training models drastically faster. And finally, multi-head attention. This is like having multiple sets of eyes looking at the sentence simultaneously, with each set looking for a different kind of relationship. It's incredibly powerful. Okay, so we've been talking a lot about words and sentences, but don't let that fool you. The really amazing thing about attention is that it's not just a language trick. This core idea of focusing on the most relevant parts of your data is useful almost everywhere. Take a look at computer vision. When an AI creates a caption for a picture, it uses attention to focus on, say, the dog and the frisbee, not the random tree in the background. Or in speech recognition, it can pay attention to the specific audio waveform that corresponds to a particular word it's trying to transcribe. In every case, it's the exact same principle at work. Find what's important and crank up the focus on that. So it's pretty clear that attention has given AI some serious superpowers. But, it's not a perfect silver bullet. It comes with its own set of challenges, and this is where a lot of the cutting-edge research is happening right now. On the plus side, the benefits are huge. You get incredible context, and you finally solve that long-range dependency problem. But the downside? It's computationally expensive. Really expensive. Because every part of the input looks at every other part. The amount of calculation needed explodes as the input gets longer. Doubling the length of a sentence doesn't double the work, it quadruples it. That's a huge deal. Plus, these models are just ravenous for data. They need enormous data sets to learn from. And finally, figuring out why it's paying attention to certain things can still be a bit of a black box. So, the next chapter in this story is all about making attention more efficient. Researchers are working on clever tricks like sparse attention, which is a way to have words only look at a small, carefully chosen subset of other words instead of the whole thing. And the really exciting frontier is multimodal AI, building systems that can use attention to understand text, images, and audio all together, seamlessly connecting the dots between what they see, hear, and read. So, there you have it. The attention mechanism was the key that unlocked AI's ability to focus. It took these models from having the memory of a goldfish to being able to understand context in a deep, almost human-like way. It really is the engine driving the AI revolution we're all witnessing. Which, of course, leaves us with one heck of a question to think about. Now that AI can focus, what should we be paying attention to?